Okay, so let's get into the cone assignment. So this cone is made of copper and 1 millimeter thickness. The dimensions are 13 millimeters high, 9 millimeters in diameter at the top, and 13 millimeters in diameter at the bottom. Other important things to consider is how parallel the two sides are. So not only is the height important, but also the parallelness of the two sides, so top and bottom. You want to ensure roundness at the top and even metal thickness at the top, roundness at the bottom and even metal thickness around the bottom as well. And finally, you want to have a finish on the outside and the inside to 600 emery. So you'll be getting quite a large sheet of copper like this. You're going to want to use a corner to begin with, because if you need to restart, you can use the other corner to do the next layout for the second start. So I'm going to start down in the bottom left corner, and I'm going to paint this in with Sharpie just so that it's easier for me to see all of my guidelines. Okay, with my dividers, I just want to draw a line of an arbitrary length and at an arbitrary distance away from the edge, just to create a flat line and avoid the bevel edge of this sheet. So maybe a millimeter or 1.5 millimeters distance spread, and I'm just going to draw a line, and that will be the baseline for my cone. The next thing that I want to do is draw a vertical line that intersects with my baseline, and I'm going to aim for about midway through the baseline. The main thing that's important to consider is that you want to leave half of the largest diameter of the cone from the outside edge. Make sure that you're holding this tight against your sheet to make sure that your baseline and your vertical line are perpendicular. All right, so now I have a vertical line and my baseline. So putting my divider needle right in the very intersection of the baseline and the vertical line, I'm just going to create an indentation right there, so that'll make the right side of the profile of the cone, and making sure you're resting the divider back in the same indentation you made at the very intersection on the left side. The next thing we want to do is mark the height, so 13 millimeters. So again, being careful to be using the same indentation at the intersection point. And mark an indentation at 13 millimeters high. I'm going to open my dividers to the height that I just marked. And just create a horizontal line at the top from which we will measure our smaller top diameter. So now on either side of the center line along this horizontal line at the top, we'll mark half of 9 millimeters, so 4.5. Okay, so now I have the outside markers for the profile of my cone. And then using a steel straight edge, I'm going to join up the bottom point with the top point, and I'm going to create a line straight through the midline. So I'm making sure that my bottom point and my top point are lined up. I'm creating a line through those and through the center line. And then same thing to the other side. I would use your steel ruler for this operation, but ours seems to have gone missing, so. Okay, and if everything was lined up properly, then the 3 lines at the very top here should intersect accurately. So you want to locate that very intersection point between all 3 lines and create an anchor mark there with your scribe or with your dividers. So now using this anchor point at the apex, I'm going to open the spread of my dividers to the top point and to the bottom point independently and swing 2 arcs. So the next thing we have to figure out is how long we need to create the arc at the top and how long we need to create the arc at the bottom for our template based on the 9mm and 13mm diameters that we need. So we're going to employ the band ring formula and do the outside diameters minus the metal thickness times pi independently. So you can now either decide to lay out the top measurement or the bottom measurement. So for the top at 9mm in outside diameter, if we employ the band ring formula, 9mm subtract 1 times pi gives us 25.12 millimeters. If you want to lay out the bottom length, then the band ring formula of 13mm subtract 1 times pi gives us 37.68 millimeters. So I'm going to just work out the top. And so I've cut a piece of binding wire to that dimension, so 25.12 millimeters, and I've just bent it carefully against the guideline that I've made, this arc line. So I've bent it to the same contour, as close as I could get it. And now you want to very carefully, making sure that it rests right against the layout, very carefully mark that length with your scribe. And then I'm going to join that marker up with the apex, and I'm going to put that line through both the top and bottom arcs of the template here. Making sure that both points do line up with the straight edge, and then bringing the line straight through. So here now is the template for my cone, and I'm going to saw this out. You can also make yourself 2 guidelines just on the very outside of these lines to cut on if you'd like, or remember to saw on the outside of these lines because you'll need that extra space to file after. So I'm going to go ahead and saw this out, leaving some extra room. Okay, so I've got my template cut out now. If the top and bottoms are not perfect, that's fine. In fact, it's better to have some excess, so just leave those as they are now. But what we want to do is flatten both the straight sides. We want to flatten them to the perfect length, so right to the very guidelines. Don't go beyond that, otherwise your cone might end up too small. So just with a hand file both those sides flat. You're checking for flatness this way, this way, always round. Okay, so once you have both edges flat, it's time to anneal. So you're going to heat up and quench to anneal. All right, so this has been annealed, pickled, and now it's time to bend. So I'm going to use my bending pliers to start this bend, and then we might have to do some malleting as well to close up the seam. We're aiming for, if you remember the band ring, having these edges line right up, so into a perfect butt joint with no gaps. And we're also looking to have the top and bottom align as best as possible. I would recommend putting your guidelines on the outside, just so that you can see them while you're bending, and it might help you to gauge how accurate you are, and then it might also come in handy after when you go to file. So I'm going to align the flat jaw of my bending pliers right at the edge on one side. I have the bending side of my pliers toward the back so that I can bend around. So I'm starting the bend on the left, and then I'll move over and start the bend on the right the same. We want this to come up symmetrically as much as possible. As we get closer, the two edges get closer, we can move the bending pliers in. I've just pushed the larger side in here, just because there's too much of a gap at the bottom. So now, as we're moving closer together, we need to get both of these sides to align. So closing that gap on the bottom. You can also start with your pliers on the small side, and that might help to have this initially line up more parallel. So it does take quite a bit of strength in your hands. If you need to anneal it again at this point, you can do that as well. But mainly you're looking for these sides again to be parallel and equally distanced apart from top to bottom. You can use your bench pin to torque with as well, just so that you have a little bit more stability and so that you can, and more resistance, and you can give your hands a bit of a break. Okay, once the two back edges are aligned, it's probably as much as you can do by hand. So then you'll grab your mallet and just ever so carefully, we're just going to try to zip up this seam by hammering a little bit with the mallet on either sides. So I'm malleting just on the surface of the metal on either side of the seam. Just to pop those two edges down against each other. So now the seam is tightening up, but there is still a bit of an angle on both sides of the metal. So to fix that, once they've come a little closer together, we can now mallet right down on the seam very lightly. You could emery, or rather you could have annealed it at this point to mallet, but I caution you to, because if you do that, it'll become very soft and easy to collapse. So I'm doing this in a work hardened state, which does help to maintain the majority of the form. So just a word of caution that you could anneal if you absolutely have to, but just be really careful in how you're malleting at this stage in that case. Okay, so I've got the seam pretty much almost parallel to each other, but there's a bit of a gap between the two edges. So to fix that, we'll turn it to its side and mallet each side along that arc. So once the solder has flowed on the outsides of the seam, just flip it over to check and make sure that the solder has flowed on the inside of the seam. If it has, then quench and pickle. Okay, so I've just taken my cone out of the pickle and I'm inspecting the seam to make sure it filled in. It's good. I have a little bit of excess here, which you can clean up now, which might be better just so that you don't end up pushing this further into the surface of the metal. And then I'm going to flip it over and just check the inside again of the seam, and it looks complete. That's great. And you also want to assess the edges, the very edges there. So to make this round, we can use a couple of things. We have our bench block with the round end of the anvil. Bench anvil with the round end. And we also have something available to us in the tech office for loan, which are these bezel mandrels. So you'll want to get a round bezel mandrel, and essentially this is like a mini ring mandrel for making small little band rings round. So we can start with the round bezel mandrel because this is quite squished, so hard to get onto our anvil, for example, without creating marks potentially, since this doesn't extend past the other side of the cone, it could end up marking up the inside if we hammer on that. So we're going to start again with this and just pushing the cone down with our fingers to start with, just to open it up a little bit. And then we'll take our mallet, and the same way that you would round a ring, you can round this. So hammering on the spots where there are gaps underneath will open it up. So once you've opened your cone up a little, you'll want to put it on the anvil. And you're going to want to pull down on the cone so that it contacts the anvil all along the length from top to bottom. And as we're pulling down, we're going to be turning as well and malleting at the same time. And you're aiming to be striking with the mallet in a sweeping motion across the whole surface, just beyond the point of contact. So just beyond where the cone, the copper of the cone is meeting the steel of the anvil. So you're checking to see from the top if it's round by seeing for any gaps. There are a few there. And also around the bottom, checking for gaps. And well, there will be a gap because it's so much bigger on the bottom than the mandrel, but you're looking to see that it's symmetrical all the way around. So there are still some little wobbly bits. If you want to true this up a little bit at this point, just to help you along, you can use ball punches of similar sizes. So here I have one that's about 8 mil or so, and this is about 11 mil or 12 mil. And just very lightly, a couple of light taps of the ball punch. Just to help round that out. So that's the top and the bottom. So you can't rely solely on the ball punches because, of course, if you don't have the edges flat the way they're supposed to be all the way around, then you're not going to have a true cone. You're going to end up with something with flat spots all the way around. So you want to really make sure that the whole cross section all the way from top to bottom is round, and you do that by using your mandrel and your anvil intermittently. Okay, I'm just coming back after the first round of forming to anneal. This is important to really get it round. So once you've formed your cone round as best as possible, intermittently with the anvil and the mandrel, then it's time to file. So I've checked my overall height and I'm at 14.5, which is good. I need that extra to true up the edges and also correct the angle all the way around of the negative space. Make sure that it's symmetrical so that we have that vertical axis that's perpendicular to the baseline. So I'm going to start by filing the top of the cone flat, and then I'm going to use that as a reference edge to mark the correct height at the bottom, and then file the bottom to the correct size. So after you've done some filing to that baseline, you'll want to check with your set square to see if that vertical axis is becoming more symmetrical and more perpendicular to the baseline. So you're looking at the negative space between the set square and the edge of the cone to see that as you're turning, everything looks pretty symmetrical in the space between those two objects. If it looks like your cone is a little high on one side or the other, then you'll want to file it down either on the top or the bottom to bring that axis back vertical. So my cone looks a little bit high on this side, which means that the angles on either side of my cone are not symmetrical. So what that means, again, if I file that down, it'll bring the surface flatter, and it'll also tweak the slopes on either side. You want to test that all the way around and just see again that everything is looking even all the way around. So another tip to checking if your two sides are parallel and to kind of get a better sense of whether your axis is vertical is to put your cone into your vernier gauge and then try to wiggle it. Anywhere that it moves, it means that that side is shorter, so it would mean having to file a little bit more on this side, in my case, to get it down to the same height. So this is, again, a good way to just check for parallel edges, and you can turn it and check it a few ways as well. So a little bit here, probably all of this distance needs to be filed a little bit. So once you've got your height established and both of your ends are parallel and nice and solid in the vernier gauge, and your axis is getting better, so this axis, the vertical axis, is getting better in terms of being perpendicular to the bottom, the baseline, then you're going to want to file the exterior all the way around, and again continue checking that axis with the set square as you're going. You can tweak that a little bit with your filing in the round and also on the top and bottom. After you've finished filing all the way around, you'll do an emery to 600, and then you can emery the inside with a, you can file it with a needle file, a half round needle file, especially on the solder seam, which you might have a need to clean up a little bit more. And then you can do some cleanup with an emery roll up, even wrapping around some emery around a drill bit and then putting that in your flex shaft to clean up the inside. All right, so when you're done, you should have a nicely finished exterior, a nicely finished interior, including and especially on the solder seam. So that's the seam. Should be flush and smooth. The edges should be emeryed to 600 as well. So top, bottom. Again, metal thickness should be even on top and bottom. And all along the exterior of the cone, the slope should be flat. So there should be one flat plane all the way around. Do one final check of your axis on the set square, of your edges and your height in the vernier gauge of the top and of the bottom. And once you've got all of that done, then you'll be ready to hand in your cone.